First, we'll look at all the different types of examples. We start with x multiplied by a trigonometric, x multiplied by an exponential, and x squared multiplied by an exponential. Also, we have x multiplied by a logarithmic function, and the logarithmic function on its own. And finally, an exponential multiplied by a trigonometric function. The final example, the trigonometric multiplied by the logarithmic function, is a bit different. We'll come to that at the end. Sometimes you'll have questions where you have to find the area under a curve. These questions require limits. The good news is you get the formula on the formula sheet in the exam. The bad news is the formula looks like this. Actually, it's not so bad. If you see where the formula comes from, then it's a bit less intimidating. It comes from the product rule. Now at this stage, I'm sure you will have used the product rule quite a few times. All we have to do is just integrate each term in the product rule, and then just rearrange this line, and we get the formula for integration by parts. What else do I need to know when I'm doing these questions? Look at these integrals. You should be able to do these without feeling dizzy. So let's start with x multiplied by sine of x. We need to link the formula to the integral. In the formula, on the left-hand side, we have u dv by dx. So we'll choose here to link the u to the x, and also we'll link the dv by dx to the sine of x. To solve the problem, we need to look at what v and du by dx are as well. So the best thing to do is set up a menu of expressions. We've already decided that u is x, dv by dx is going to be sine of x. So with a quick differentiation, du by dx is 1, and v is negative cosine of x. Now we're ready to use these expressions and fill in the rest of the formula. So uv becomes x multiplied by negative cos x. Need the brackets there because it's a multiplication, not a subtraction. And we subtract the integral of v du by dx. V is once again negative cos x, and du by dx is just 1. I'll use a dot for multiplication here. Now, all we need to do is just neaten up the expression. The first term becomes negative x cosine x, and the second expression is simply the integral of cosine x. So finally, our final answer is negative x cos x plus sine of x plus c. Don't forget the constant c. Next, we're going to look at x multiplied by e to the power of x. Same technique. We look at u dv by dx on the left-hand side of the formula, and we're going to assign u to the x, and we're going to assign dv by dx to e to the x. Because we also need v and du by dx to complete the formula, let's put this in the menu of expressions on the top right corner. U is x, dv by dx is e to the x, so a quick integration and differentiation, and we have our complete set of expressions. Let's then put them in the formula. That's u multiplied by v minus the integral of v multiplied by du by dx. This one's even easier. There we go. And we can factorize as e to the power of x multiplied by x minus 1 plus c. This one, an extra step. Why is that? That's because we've got x squared. Once again, we'll assign u to be the x squared and dv by dx to be e to the power of x. Quick differentiation and integration, and then substitute these values to complete the formula. uv minus the integral of v du by dx. You'll notice here, though, that you're left with an integral of x multiplied by e to the power of x. This looks quite familiar. In fact, it's exactly the same expression as before. So what we're going to do is repeat the process from the previous slide. So the integral on the right-hand side of the expression, we will now use integration by parts again. We have here u multiplied by v minus the integral of v du by dx. And now it's a matter of simplifying. We know that if we integrate e to the power of x multiplied by 1, we simply get e to the power of x. And don't forget c. Let's factorize e to the x multiplied by brackets x squared minus 2x plus 2, and we must not forget the c. Now we have a different class of integral, x multiplied by the log of x. This time we're going to assign our u and dv by dx differently. Instead, we're going to make u the logarithmic function and dv by dx will be x. Just like before, we also need to find v and du by dx to complete the formula, so I'm going to use the menu of expressions. Remember, if I differentiate log of x, I get 1 over x, and if I integrate x, I get x squared over 2. Now it's a simple matter of filling in the rest of the formula. I've done u multiplied by v, and now subtract the integral of v multiplied by du by dx. The good thing here is that the integral actually simplifies very, very nicely to x over 2. And this becomes very easy to integrate, and we're left with this expression at the end. If you want, though, you can factorize, and we get this rather simpler expression here, and don't forget the c. This one's a bit different. It's just log of x on its own. How are we going to do this? Well, as before, u is going to be the log of x. Now, what is dv by dx going to be? This time, though, we're actually going to create another term, and that term is 1. So my integral is actually going to be log of x multiplied by 1. The table of expressions on the top right, u is log of x, dv by dx is 1, so differentiate, and integrate, and I've got my complete set of terms. uv becomes log of x multiplied by x. I then subtract the integral of v multiplied by du by dx. And this really becomes very simple now. We'll write this as x log x, and it becomes the integral of 1, which is simply x. And don't forget the c. Let's factorize, and don't forget the c. Now for the killer question. This is an exponential multiplied by a trig function. I'm going to start by calling the integral I. This is actually to make life easier rather than add more letters to the mix. So this time we'll assign u to e of x and dv by dx to sine of x. It didn't really matter which way round we did it. We'll end up with the same result with a similar number of steps. So let's differentiate our u, which becomes e to the x, and integrate our dv by dx, which becomes negative cosine of x, and then let's complete the right-hand side of the formula. Here I get e of x multiplied by negative cosine of x, and I subtract the integral of v du by dx, which is negative cosine of x multiplied by e to the power of x. Let's simplify a little bit. So now on the second line we'll have negative ex multiplied by cosine of x, and subtract the integral of ex cosine of x. You'll notice the negatives have cancelled each other out. But are we getting any closer to the answer? We've got another expression where an exponential is multiplied by a trigonometric function. How do we get around that? Well, we carry on and we repeat the process of integrating by parts. I'm going to do this one in red. Once again, u will become e of x, and dv by dx will become cosine of x. And now let's integrate. So uv minus the integral of v du by dx. Are we getting any closer to the answer? Yes. You should notice something. What is that new integral? It's actually the same as the original question. So let's rewrite the whole expression. We'll factorize the negative ex cos x plus ex sine x and rewrite it as e to the power of x multiplied by sine x minus cos x. And now we'll call that I. Look carefully how we did this. Now add I to both sides, and we're getting closer to our answer. 2i is ex sine x minus cos x, and I will simply be half of that expression. Don't forget the c. Here, it doesn't matter how many times you try it, which way round you have the u, the dv by dx, you're just going to go around and round in circles. The integrals will expand, having more and more terms. It's just impossible. This is an example of an expression which can't be integrated. So let's go back to the ones which you can integrate. The yellow ones, x multiplied by a trig or exponential function. You always set it up by having the u as the x or the x squared, and the dv by dx as the trig or the exponential function. Here we have the blue functions. This time our u will be the log function, and our dv by dx will be either x or 1. Here, when we have the exponential multiplied by the trigonometric function, it doesn't matter which way round. You've just got to be careful and ready for a very, very long question. And finally, the trig logarithmic won't work at all. This is taking it a step further. You notice you've got limits, so you've got to know what the cosine of pi is, the sine of pi is, as well as the cosine of 0 and the sine of 0. And what makes it really difficult is the negatives. Negatives flying all over the place. You really have to be careful, but we'll deal with that another time. Thank you for listening, and I hope that will give you more confidence when integrating by parts.